All right, so here we have another set that we could solve for y. And so what we're going to do is we're going to take everything else to the other side and keep the y, and then we'll change the sign. So we have the minus y plus 7x equals 4. So I'll subtract my 7x. I get a negative y equals a negative 7x plus 4. Now I need the opposite of that, so I'm going to divide everything by a negative 1. And so y is equal to, well, that's going to be a positive 7x minus 4. Same thing on this one, minus y minus 3 plus 7x equals 0. Well, this time it's going to be easier just to take the y to the other side. And so we get, now we have a negative 3 plus 7x equals y, or y equals 7x minus 3. Okay, now notice we have the same slope here. All right, so that's going to mean we're having parallel lines. Remember, if M1 equals M2, those lines are going to be parallel. So we have different intercepts, though, and what I'm getting from that is we're not going to get a solution because we're going to have two parallel lines not ever crossing because they're going to be parallel starting at different points. So let's just graph them and see what we have. So we have 0, negative 4, and then we're going to go up 7, right 1. And we don't have enough room to go down 7, and we have enough to go up 1 again. So right 1. So that looks, well, that doesn't look very good. That's what it looks like. Still not good, but it's better. And then the other one starts at negative 3. And then we're going to go up 7. 1, 2, 3, 4, 5, 6, 7, right 1. And the way this is drawn, those aren't really crossing. It's just badly drawn. It should be more straight down like this. And then can we go down 1, 2, 3, 4, 5, 6, 7, left 1. And again, this should be more straight down here. So this is when you have these really, really close lines, it's going to be really hard because you're going to not be able to draw those lines very straight. And then basically it's going to just parallel. I'm just going to draw parallel even though that's the point it goes through. Because we know when they have parallel lines, different intercepts, they're never going to cross. And so there's no solution. Okay. So when they're this close, you really have to have a good line drawn on both two different equations. Otherwise, it's going to look like they do cross, which in this case, they really don't cross. All right, how about let's do another one where we plug in x and get y, or plug in y, get out x, okay? So let's have our x, y, and we have our x, y. Maybe make that one a little longer. And here we're having multiples of 2, it looks like. And so what I'm going to do is I'm going to say, well, let's do maybe 0 to 4 and maybe 0 to 4. Not sure what we'll get, but let's have those two. Now, if we plug in 0 for x, that goes away. And divide by negative 4, we get a negative 2. Okay. Now, what if we plug in a 2? That's going to be 4. So if we subtract 4, we're going to get 4. Divide by a negative 4, we're going to get a negative 1. Now, if we plug in 4, that's going to be 8. Subtract that, that's going to be 0. And so this will be a 0. All right, what about the second one? If we plug in 0 here, divide by a negative 6, we're going to get a negative 2. Plug in 2, that's going to be 6. Subtract that off, that's going to be a 6. Divided by negative 6, that's going to be negative 1. And we plug in 4, that's 12. Subtract that off from here, that's 0. And so we get 0. And so what I'm noticing is these have all points in common. So that means we have a single line, and therefore we're going to have infinitely many solutions, but let's just draw it. So we'll have 0 minus 2. We'll have 2 negative 1, and we'll have 4 0. Okay, and so our line does something like that. And then we plot those same points again, and we have that. And so what we get is infinitely many solutions. Okay, and so that would be our answer to this one. How about this one? Well, this is back set up nicely to have, our intercept and our slope. Now, what do we know? We see we have the M1 equals M2 again, and we have different intercepts. So I'm going to bet that we're going to get parallel lines that don't intersect, and so there's going to be no solution. But let's see what we get. And again, my drawing might not even show what we get, but let's see. So 0, 4, we're going to go up 1, right 2, up 1, right 2. And so if we go down 1, left 2, then we have down 1. That's 3, not 2. That's the problem. So down 1, left 2, there we go. So it looks something like that. Now this one's 0, 1. We go up 1, right 2, up 1, right 2. We can go down 1, left 2. And again, we get some line that looks like that. And those two lines are parallel because we know M1 equals M2. And so therefore the solution is no solution. All right, let's stop there. We'll come back for more.